Assalamualaikum warahmatullahi wabarakatuh. In this topic, chapter 12, we are going to see the idea, number 1, equilibrium, and together with the concept of elasticity. So here given in the picture, if you have a uniform meter stick, then you will find that the whole weight will be supported at the center. Where here it says here 50 centimeter marking. So what this guy is doing is he start with placing his hand at the left end and at the right end, and then move his hand towards the center. He figured out that both hands will meet exactly at the center because of the previous concept that you have learned, that this is the position where center of mass is. And therefore, you find as well in terms of the vectors, weight is downward and normal force is upward. So we are going to use this concept in detail for examples later on. Now, the first part of this topic, chapter 12, is all about equilibrium or static equilibrium. And the second part will be the formation of object because of loading, ataupun diletakkan pemberat atau dikenakan forces. So, the object experience forces and therefore changes in the shape itself. Right, let's start with the first one. What will happen if object is in equilibrium? So, you have seen the idea of what we call torque, that a product of R and F, and both must be perpendicular with one another. Now, in the case of the rotational equilibrium, you find that there is no acceleration, including angular acceleration. No here represent the value, it's 0. Now, the effect that it is 0, okay, then you find that we need to use what we call as conditions of equilibrium. We have two conditions of equilibrium. Number 1 coming from previous topic, when object is at equilibrium, the net force is equivalent to 0. Now, the second one is the object must as well be, remember earlier, yes, angular acceleration 0, hence net torque summation hasil tambah torque would be 0. So that object don't rotate, neither move translational. Maknanya dia tidak bergerak ke kanan, ke kiri, ke atas, ke bawah, juga tidak berputar. So this is what we call conditions. Syarat-syarat bila mana objek berada dalam equilibrium. No translational, neither angular speed. So object must be at rest. Alright, therefore, from the two conditions just now, hence, we have to look in the x component and y component separately. And therefore, you will arrive with two expressions. The first expression now can be open to two components and getting two equations. Okay, so these conditions will give you equations, and torque, net torque is equivalent to 0. Alright, let's look at examples on how to use these conditions. Now, for example 12.1, we are going to go and look at example 8.8 because they are the same and with numbers. Let's now turn to example 8.8. Alright, before we look at the example, bear in mind the expression of conditions that we are going to use is, number 1, the whole net force should be equivalent to 0, whereby we must consider it in different dimension separately. And the third one is net torque would be equivalent to 0. Now, in this example, you will find in situation when it's not stable, not equilibrium. The guy, there will be a rotations. Okay, so here, however, is a situation where it's balanced. Means that the torque applied or net torque to the situation is 0. So let's look at how we are going to apply it. Number 1, let's take note on the given data. Number 1, mass of the woman is 55. The whole length of plank is 4. Mass of the man here is 75. And mass of the plank, this is 12 kilogram. Okay, now let us substitute the number into this figure. So the lady or the woman, 55 times 9.8, we are going to write it as 55G. Later on, we are going to substitute number. Mass of the plank, so 12G. Mass of the man, 75G. And this is the unknown normal force. The first question, first compute the torque. They want you to calculate torque on the axis that passes through the pivot point. So where is the pivot point? We are going to label it as 0 here at the fulcrum. Now from there, you should, where should, this is the question, where? So indicating an unknown distance, which is labeled here as X, should the man sit down so that the system is balanced. So we are looking at situation here at equilibrium. Now, from the first concept of, or perhaps you can choose any, force X or torque. So you find that the one which exert torque, consider that 0 is the period. Okay, 0 here is the period. You find that the guy will make the plank rotate in this direction, which we call it as clockwise. And because it's clockwise, then it's a negative torque. What about the lady? She will rotate the plank in this direction, which is in the direction of counterclockwise, and therefore she will provide a positive torque. And because of that, recall that torque individually is a product of RF sine theta. In the case of the lady just now, she is here. This is the 0 just now. This is the force, which is equivalent to the weight 55 kali G. And the R is therefore here, which is equivalent to L, 2 meter. L over 2 meter. And mathematically, this is 2, this is 55, and this is 90 degree because the force and the R is perpendicular to one another. And therefore, the calculation of the lady just now becoming 55 times 2 only. While the man, okay, look at how the calculation of the torque. This is torque for the man. And this is torque for the lady or the woman just now. So notice that this is carrying a value equivalent to 75 times G and times the R, which is the X. R is the unknown X. And again, you find that the angle here is 90 degree, because if you are to draw for the man just now, he will look something like this. So this is the force, 75G. This is the force perpendicular to the lever arm just now. This is the 0 or at the pivot just now. So this is the R, the unknown value as X. So that's kind of how you substitute the number. And from there, okay, so you are going to write it something like this. Negative torque 75G, this is the force, times the R value, which is X, plus 55 times G, and times distance, which is 2, equivalent to 0. So X will be similar to what's given here, 1.47 meter. Give it a try. Okay, let's look at B. Find normal force value exerted by the pivot if the plank is 12 kilogram. Right, according to the figure, this is the only contact force. Therefore, this is why there is a normal force exerted in this direction. Now, what happened next is we are going to apply the conditions of equilibrium regarding net external forces. In what directions? Okay, let's look. The first one, let's start with something x equivalent to 0 and in the y direction as well, simultaneously. Now, observe the figure. Do you see any forces in the x direction? None. So, hence, we are not going to use this. So, not use. So, let's look in the y direction. How to look at it? Look at everything as a whole. Everything as a whole. So, by looking at everything as a whole, you will find there are 4 forces altogether. 1, 2, 3, 4. And therefore, from the concept of Newton's law, the up forces, which is N, plus the wake. However, the wake is downward, and hence we are going to write it as 55G, number 2. Number 3 as well downwards, so 12G. Number 4 is 75G, and that's it. The whole thing, when they are summed up, must be equivalent to 0. Hence, you will find that normal force is a product of 55 plus 12 plus 75. Or should I say, the whole weight of the woman, the plank, and the man are the value of the N itself. And substitute that G is equivalent to 9.8. So you should arrive with the answer as given here. Observe, mass man, mass plank, mass woman adding up together because of the concept of factorization. Try it. Now let's look at C. You are to repeat again the concept of torque. But this time around, you are going to change the axis of rotation, the O value, at other position. And in this case, that position is at the left end of the plank. Now, since it's at the left end, let's rub away this O, axis of rotation, and change it to be here. So, the concept of torque is all about the R times F together, and considering that they are perpendicular with one another, and that's the reason why you have sign. So, let's take away the direction of here as well. We are going to see that everything would change. If this is now axis of the rotation at the woman, you will find that 12 or wake of the plank will make this plank rotate in this direction, and man will make it experience torque. What experience torque? The plank will experience torque in this direction. Okay, you can use the right hand rule to look at the direction, and you will find that this is a case where your thumb point in for both case, and therefore torque by the plank is negative, torque by the man is as well negative. Next is the normal force. You will find that normal force will make the rotation of the plank in the direction counterclockwise, and therefore torque by the normal force is a positive value. Now, how about torque by the woman? You will find that torque by the woman is 0. Why? Because of R is 0. Let's recall what is R. R is the lever arm, moment of lever arm, where it's a distance from the axis of the rotation to the force applied, and that's the reason why it's 0. Let's do a little of substitution here. So torque of the man can be calculated by using R, which is the R is from here to here, which is 2 plus X R, okay, times the force, which is 75 G, and it should be negative product. What about torque by the plank itself? So negative R is 2. So look again. So this is R of the plank, which is equivalent to the 2 value, 2 meter. So 2 meter times 12 G. And what about the normal force? So very simple. The force itself is N, and the distance is as well 2. So times. Now, next question is we don't have the N value. Okay, what is the N value? Okay, now let's leave that as an unknown for the time being. Okay, look closely at how we substitute earlier. So negative 75 times 9.8, and the 2 meter plus X. Let's double check. 2 plus X, 75 times G, and negative torque. And plank itself is, what about plank? So the weight times 2 meter. The weight times 2 meter. Right? And lastly, the normal force, which is positive, positive 2 meter R times the normal force itself. Let's double check. Yes, it's a positive value, and the 2 meter as the R. So let's look again at the equation. And therefore, to get the X here, we have two unknowns. Number one, the X value. Observe that you have two unknowns actually, X and N. So the main question is asking you to get this X, the position where the man is supposed to sit down so that the plank is at equilibrium. And therefore you need this N. Where do you get the N? Go upward again. Recall that you have done this before. In the condition net external force is 0, specifically in the Y direction, will give you the value of N. In conclusion, when you change the axis of rotation, technique related to torque changes. Okay. However, the value of the normal force and such remain the same value. Arrive with the same answer by the given technique earlier. Give it a try. Now for example 12.3, we're going to look at example 8.10 for the data. So let's turn to example 8.10. Now in this example 8.10, you will now find all the three equations in the X component, in the Y component's forces, and finally torque would be in use. So kita akan ada tiga unknown usually bila ada tiga bersama serentak. So in the given figure, you will find that there is one ladder. Dia akan rest on a surface as in the figure. So tugas pertama kita adalah untuk draw free body diagram of forces, ataupun paling kurang fahamkan apakah forces-forces yang bertindak ke atas ladder ini. Yang pertama, it says here the ladder is a uniform ladder and this is the wake. Since it's uniform, perkataan uniform indicates that this 50 Newton would be here at the center, tengah-tengah. Kalau panjang dia 10 meter, maka jarak ini 5 meter. Next is, if the ladder is on the verge of slipping and the angle is 50 degree with the ground, find the mu, coefficient of static friction between the ladder and the ground. Alright, now that was one missing concept. It rests on a smooth vertical wall. Okay, let's start with the friction. If it's supposed to falls down or slip down, you will find that it will move in this direction where the upper part will slip downward. So kita boleh labelkan sebagai delta X, ya. And because of that tendency, it doesn't happen. Remember, this doesn't happen. But yet, if there is no friction, this is how it will slip down. And that makes sense, that the friction will be in the opposite direction. Let's take away everything. Next is, what about the vertical surface? It says here that on the vertical surface, it's just smooth. No friction at all. And because of that, there is no friction applied in the vertical wall. So, ini untuk memudahkan soalan lah. Jadinya, kita lihat the forces that we have seen earlier. Since this is a surface, this is also a surface, there is what we call a normal force, a contact force. Okay, normal force, where the ladder press onto the surface, perpendicular to that, and this is how it looks like. This is the normal force we are talking about, out of the out of the surface. Now, this is our second surface, out of it perpendicularly. So, there is one more normal force. However, we would not be using the same symbol supaya kita tak confused, because the symbol indicates the value. Jadi, kita tukarkan symbol ini guna symbol lain. P, Q, R, any symbol would do. But here we opt to use kita punya symbol sebagai P. Tapi understand that this is actually normal force. Alright, now that we have understand why the forces is as such, baru kita boleh process the info using the three conditions. Two conditions but end up being three. Yeah? Now, on the figure, okay, we are going to start with external forces. You will find that the one which is in the X direction is 1 and 2. In the Y directions, 1, 2. Normal force and the wake. And how do we put it into the expressions? Let's now look at the answer. In the X direction, pointed to the right is friction, pointed to the left is P. So that's the reason why F minus P equivalent to 0, and hence friction value ni sama dengan P. Okay, now since the question nak tanya coefficient, and in this equation kita boleh kembangkan lagi that friction is coefficient times the normal force. Jadinya inilah equation rujukan kita. Now from this equation kita ada tiga-tiga tak tahu. Jadi leave it for a while. Mu tak tahu, normal force tak tahu, P as well we have no idea what is the value. So let it be first. Sebab kita akan masukkan daripada rumus-rumus yang seterusnya. Kita ada 3, so 1. Let's now look at the second one. Y adalah normal and also 50 Newton. So look at how they are substituting. N tolak 50 sama dengan 0. Maka kita dapat dah N equivalent to 50 Newton. Let's partially substitute the value. 50 Newton. Now that we seen it again, equation number 1 ni, kita lihat kita ada satu lagi unknown. P value. P force value. So kalau kita dapat P force value, then we can now calculate what is the value of the coefficient. So where do we get this one? Kita akan dapatkan dia daripada konsep that net torque is equivalent to 0. Now when it start involving torque, then we have to decide where is our axis of rotation. Okay, here they have provide you an idea that axis of rotation, please put it as at this location. But as you understand, when object is at equilibrium, axis of rotation can be anywhere. However, since you are interested to find P value dalam torque, don't put axis of rotation exactly at P. Put it somewhere else. In fact, it's very, very helpful that you place it at here because there are two forces at this location, and because of the R for N and F is equivalent to 0, you will find torque for both here is equivalent to 0. And hence torque is only because of P and also 50 Newton. So by setting ni, okay, by setting this location as axis of rotation, you will find by using thumb or right hand rule that the curling, okay, or your rotation of torque would be in this direction because of force P, and because of this is a positive value. The value of R is from here to here, and therefore R is equivalent to 10 meter. What about 50 Newton? It will be in the opposite direction, okay, because when you apply the right hand rule, you find that your thumb is directed into the page. So this is a case where it's clockwise, while torque for P is counterclockwise, and that's the reason it's positive, and therefore this one is a negative. So in terms of the torque itself, because of 50 Newton, you will find that the value should be 5 times 50 R, or R is 50 together with sine, okay, something, sine theta. Alright, let's partially look at the substitution. So note that torque by the friction and also torque by the normal force is equivalent to 0. 0, 0. So these are the given values. And look at, this is the R for the weight of the ladder itself. However, our concern is how do we get the angle 50 and 40 here. Okay, now let's look again at the concept of torque, where torque is R times F sine theta, and recall that the theta is between R and as well F. So let's troubleshoot in our figure for this 40 degree. This is the R, and this is the force, and therefore the angle is here. Since this is the angle, this is 50 degree, then this should be 90 minus 50, and that's the reason why it's 40. Now to get this 50, so let's look at torque by the P. So this is the F, the force, which is P itself, and therefore this is the R itself, and their angle is here. Notice that the angle is zigzag, 50 and 50. So that's the reason why we do substitute it as 50. Alright, now that you have this, recall your aim. Your aim in torque is to get the P value. once you get the P value, which in this case is 21 Newton, you're going to substitute it here. This is 21 Newton. And therefore, you can now calculate the value of the coefficient by 21 dividing by 50. Let's look at the answer. 21 divided by 50, 0.42 without units because newtons are being cancelled out. Now, give a try at the exercise down below, whereby coefficient is now changed or given as 0.36 meter and the angle changed into 60 degree, and you are asked at what distance will a painter able to climb up the ladder before it begins to slip. Maknanya ada tambahan satu lagi berat iaitu 70 kilogram. Tukang cat panjat, berapa jauh dia boleh panjat along the ladder. Now our next example is 12.2, which is standing on a horizontal beam where you will need to analyze the forces acted on the beam. However, it's quite similar to example 8.11 and therefore we are going to go straight away to example 8.11 to discuss further. Now let us turn to example 8.11. The title is walking on a horizontal beam. What is beam? Here is it. In this figure, you will find that there are three types of forces. Number one, weight, tension, because there is a string, or should I say cable. And finally, there was this additional force, which is called as or labeled as R, because of the beam would be pinned or nailed to the vertical wall, as in the figure. So in the case of what does it has relationship with the torque, try to imagine that this cable or the tension supporting the beam break apart. So you will find that this beam will tend to rotate. Maknanya dia macam jatuh. Tapi because of the R here, most probable it will still be contact. However, just making half of rotation like this. Okay, from this to swing downward. So we find that in order for the object to stay equilibrium, then the two conditions which resultant force in the x and y must be 0, including that the net torque, summation of torque, must as well be 0. Now let us go through the question, where from the question we will identify the free body diagram, where we will look at figure A and figure B. Figure C and figure D are meant for the exercise underneath this example. Now, you will find that there was this R force. Okay, not to worry much about this R force. Most of the time, the direction is quite similar as shown in the figure. If another example comes similarly, okay, if we have another example which is similar to this one. So the situation is you have a uniform horizontal beam. So since it's uniform, the weight 300 Newton should be at the center. Since the width of the beam is 5 meter, therefore this is 1.5 meter. Okay, and this 2.5 meter. So this is the 300 just now. We have the beam attached to the vertical wall, which indicated by this black dot here. So this is a pin. Now a pin is quite similar to the nail, except that if you nail an object or nail something to the wall, then the object would not be able to move around. So pin is used here so that it as well able to allow the beam to rotate. Now because it's now able to rotate, being at equilibrium, it means that the conditions of equilibrium, which number one, the net force should equivalent to 0 and the net torque equivalent to 0 because it able to rotate, but in the figure shown that it's static and being again at equilibrium. Dia stable, tak bergerak, tak rotate. Jadi sistem ni stable. Jadi kita boleh pakai the two expression. Okay, now so shown here as well that the end here is supported by a cable. Now since this is a cable, which a cable quite similar to the concept of a string, it's thought when it's thought tegang maka ada tension. So we find that the direction of the tension similar direction as the string and away from the object. So this is how. So the last one, oh yeah, okay, we have the angle given here as 53 degree with the horizontal as in a figure. Now if this person in the figure is 600 Newton and he stand 1.5 meter from the wall, therefore this is how it looks like, 600 of the man, and this is the distance 1.5 meter from here, from the wall. So you are to find number 1 the tension and number 2 the R. Okay, all of a sudden there is a R value. Now this is an additional force because the beam is pushed onto the wall. Since it's pushed onto a wall, we will find that there is a force in the X and Y direction. And the direction when it's combined is as in the figure like this. Or if we open up, X and Y as in the figure. Alright, so we are going to use this condition of equilibrium and solve to get T and R value. Let's go. Alright, let's start with the resultant force in the X direction and Y direction equivalent to 0. Now, according to this figure, they are around, okay, you should notice that this is a product of T sine theta. So it means that T has a product of Y component and also X component, T cos 53. The same thing happened for R, which is R cos theta. However, we are not sure of this angle, so leave this as an unknown. And it goes the same with the Y direction, R sin theta. So how many is there in the X component? So this is your first X, your second X. Okay, so we have only 2x in the direction of X component. So mathematically, when they are summed up, should be equivalent to 0. So let us now visit the answer. So in the X direction, we find that Rx minus T cos 53 is equivalent to 0. Should I say here as R cos theta? Okay, but it's written in such a way. This is just technique, yeah. So you will find that in the Y direction, there was this value of number 1, Y1, number 2, Y3, and 4. So there are 4 elements altogether, and mathematically it should be R sin theta plus T sin 53 minus 600 minus 300 should be equivalent to 0. So let's troubleshoot. There are 4 just now. So R in the Y component plus T sine minus both with equivalent to 0. Alright, so we will find after this, why is it that the solution leave it in the form of without angle. Okay. Next one is, we find that, we have to go back to the solution just now and we will find something. We should notice that in both expression, we have R unknown, theta unknown, T unknown, and same goes with this one. So you will find that you might be needed to go and find tension from the other solution. Okay, it's just not enough. And because here, okay, by this technique as well, you will find that Rx and Ry does not have the same answer. So leave it for a while. And let's now turn to the torque. Remember that when you apply the concept that net torque is equivalent to 0, you can place the axis of rotation at any position. Number 1. However, because you have no idea what is the T value, what is the R value, including the angle, it's best to opt that it's here. So axis of rotation to be at the left where attached or at the pin positioning. And because it's at the pin positioning, let's now determine the direction of torque. Okay, direction of torque for H1. So you will find that torque given by the R would be 0 because the R distance or lever arm is equivalent to 0. So we can neglect the torque from R force. So in the case of tension, the torque would be in this direction, whereby counterclockwise, or you find that your thumb is directed, okay, out of the page. So it is a positive torque, while both weight will end up making the beam, akan menyebabkan beam tu rotate clockwise. Now, so both would give you negative. So altogether, we have 3 torques interacting with one another, add up becoming 0. Now, before we proceed, let's double check with their angle, sorry, not their angle, their distance. So the lever arm, the R for tension should be equivalent to 5 meter. Thus 300, the weight itself should be 2.5 meter. And the man should be 1.5 meter. Alright. Now, however, the angle 53 need to be considered, where else for 300 and 600 Newton, the angle is equivalent to 90 degree with one another. So we might disregard the angle for the 90 degree. Alright, let's now look. So we expect torque by the tension would be minus with both torque from the wakes. Right, so this is the torque from the tension. Okay, the lever arm is 5 meter, while this is unknown. Regarding weight by the man, this is weight by the man, and also this is 2.5 meter, where this is weight of the beam. Okay, and when you add up, it's equivalent to 0. Now, according to this expression, there is only one unknown missing, and that one unknown missing is the tension value itself. So as you substitute properly, you should arrive with tension 413 Newton. Now that you have 413, bring it into the x and y components as such in this here, and as well here. You will get the value of R in the x direction, which in this case should I write as R cos theta 249 Newton, R in the y direction, which is R sin theta, as 570 Newton. Okay. If let's say that they do not want the component, okay, let's double check the question. Okay, the question would like you to calculate the force. So since it's asking for the force, the right technique technique yang sepatutnya, unless question says component, then this is okay to leave as the answer. But since it's asking for, again, it's asking for the value of force R alone, then the next step should be R equivalent to R in the x component square y squared and square root, the two product. Okay, so we expect mathematically 249 square and 570 squared and square root both number, you will arrive with one singular value. So I repeat myself again, since the question is asking you the force R without saying that they want the components, then the expectation should be to this technique. Okay, 249 squared plus 570 squared. Okay, however, if it does says please calculate the component, then I will say 249 570 Newton is sufficient. Thank you.